Welcome to DragginMath. Let's learn about factoring expressions. Let's say you have the expression a plus a. This is the same as 2 times a, and you may prefer to see it that way. So put your finger on one of the a's. Which one? For this simple problem, choose the one on the left. But for other problems, you may sometimes want to choose the one on the right. Drag that A up until it turns blue. The blue color is important because it tells DragginMath something about what you intend to do with it. If the node you're dragging isn't blue, DragginMath will either do nothing or else do something different that you didn't intend. Now drag that A down onto the other A and lift your finger. See the result 2 times A, which is what we wanted. Now let's try something a little more interesting. Put your finger on the A at the bottom left of the tree. Drag it up and onto the A at the top right of the tree. Did the node you dragged turn blue? Yes, it did. Now lift your finger and see the result 5 times A. You only interacted with the nodes at the far ends of the original expression, but DragginMath looked for nodes that were equal everywhere between. If the expression contains any nodes that aren't equal to what you're dragging, then the transformation fails and everything goes back the way it was. Let's look at a more complicated example. Drag the times at the lower left onto the times at the upper right. Lift your finger and see the result 3 times A times B. So the terms you factored don't have to be simple operands. They can be complicated subexpressions too. Inside DragginMath, this is called factoring by counting. Because that is what it's doing, counting factors. For this to work, all terms must be enough like each other for DragginMath to easily see they're equal. If they aren't so easily equal, you'll have to help it. So far, we've factored expressions only over addition. But you can factor over subtraction too. Or some mix of addition and subtraction. Also, you can factor over multiplication or division. Or some mix of multiplication and division. Notice that the resulting operator when you do this is raise, not times. DragginMath also does another kind of factoring. This is called factoring by extraction, once again because that's what it does. This undoes the work done by the distributive property. Factoring by extraction also works for arrays with multiply and divide. This undoes the work done by two of the most basic rules of exponents. When introducing a new idea, it's usually better to start with a small problem. But for this next example, it's better to use a bigger problem. Switch to the small font to see all of it. Both kinds of factoring, factoring by counting and factoring by extraction, work by looking for terms that are equal. Sometimes you need to factor things that aren't equal. This is like cleaning your room when it's messy. You need to put all the books on a shelf, socks in a drawer, and shirts in the closet. So let's take a look at our messy room. Here we want to collect all of the A's, B's, C's, and D's together. This kind of factoring is usually called collecting like terms. DragginMath won't do this automatically, but it can help you do it using the commutative and associative properties along with factoring by counting. First, commute all A's to the left. Next, reassociate operators from the bottom A to the top A. Notice we're not dragging the A's to reassociate. We're dragging from and to the operators that own the A's, because association is a relationship between operators, not operands. All of the A's are now together in one place. And we can factor these together into one term. Now commute all B's to the left. Reassociate operators from the bottom B to the top B. Once again, don't drag the B's. Drag from and to the operators that own them. Factor the B's together. Now do it for the C's. The D's are all that's left, and they're already together. This isn't a DragginMath design feature. This is math doing what math does when you know how to use it. DragginMath makes the structure of math visible, so you can more easily see and do things like this. That's all for now.